All right, today we're going to build off something you already know. You've learned how to multiply binomials using an area model. When we multiplied binomials, we started off in factored form, and we multiplied this binomial by this binomial, which were our two factors, and we put them on the outside of the box. Then we multiplied the outsides to find the area for each square. And we ended the expression by combining our like terms to get my standard form. Today, we're going to be doing the opposite, a process called factoring. When we factor, we are simply dividing. We start with the expression on the inside, and then we work our way back to the factors on the outside. Same area models, same boxes, just a different direction. So let's look at our first example. X squared plus 5x plus 3x plus 15. And our goal is to take this and rewrite it as a product of two binomials, aka factored form. We're going to use structure and patterns to let the area model guide us. If you notice, I placed each one of the terms already inside of the box. The most important part is to simply ask yourself, what does each row and each column have in common? It doesn't matter if you do rows first, columns first, or even a single box. It's all about pattern and structure. So let's look at this box, x squared. The goal is to figure out what can I multiply by to get x squared. So if we look at the structure of our previous problem, what did we multiply to get x squared? Because we can rewrite this as x times x. That means on the outside of this box, I will put x and x, because x times x gives me x squared. So we're going to use these two outsides to help us figure out the rest. So let's look at this box, 5x. And I want to know, what am I going to put outside of this box that I can multiply 2x to get 5x? Hopefully you said 5. Because 5 times x is 5x. Well, what can I put outside of this box that I can multiply by x to give me 3x? Hopefully you said a positive 3. Because x times 3 gives me 3x. And so then you say, well, Ms. Carter, we didn't do anything for 15. Well, what is 5 times 3? 15. So now the values that I have on the outside of my box gives me my two binomials. Across the top, what would be the first binomial? X plus 5. Well, down the sides, what would be the second binomial? X plus 3. So factored form, aka product of my two binomials, would be x plus 5 times x plus 3. So let's use our Desmos graphing calculator to make sure we're right. We already have our original expression written in there, right there. And so now we're going to type our factored form, x plus 5 times x plus 3, to see if they match. Do they match? Yes. So we did it right. All right, let's look at our second example. We have a 4-term polynomial, d squared plus 7d plus 3d plus 21, and they want me to write it in factored form, aka two parentheses or two binomials being multiplied to each other. So what is our first step? What are we going to do to the inside of this? We're going to write our 4-term polynomial, d squared plus 7d plus 3d plus 21. So the goal is to find the outside. What can I put on the outside of the d squared box that's going to multiply to d squared? Hopefully you said a d and a d. So I'm going to use these two to help me fill out the rest. Well, this inside says 70. What can I multiply by d that will give me 70? Hopefully you said a positive 7. Then I look at this box. I can ask myself two questions. What can I multiply by d to give me 3D? Or what can I multiply by 7 to give me 21? So D times what will give me 3D? Hopefully you said a positive 3. So my factored form would be D plus 7 times D plus 3. We're going to use Desmos to check and see if we are correct. Now, I don't have the letter D in my Desmos, so I can't type a D in. That's why it says X instead. So when I get ready to type my answer, I'm going to say X plus 7 times X plus 3. And it's right because they match. All right, let's look at example 3. We have x squared minus x plus 4x minus 4. So what should we do first with our 4 terms? Like all the other examples, we're going to take our 4 terms and write them in each square. So we have x squared minus x plus 4x minus 4. And we want to see what will go on the outside of each boxes that will multiply to the inside of each square. So let's look at our easy box where we just have x squared, which means we have 2 x's, which means that will go on the outside of each box. But what can I multiply by 4? What can I multiply by x that will give me 4x? Hopefully you said a 4. Because x times 4 is 4x. But let's look at this box that says a negative x and a negative 4. We can look at it one of 2 ways. What can I multiply by this x that will give me a negative x? And what can I multiply by this 4 to give me a negative 4? So what number is in front of this x if I don't see one? Right, so we can take that and we can rewrite it as negative 1x. And so to get negative 1x, I will multiply x by negative 1. So we have our factored form. X minus 1 will be one of my parentheses, and x plus 4 will be the other parentheses. Let's check our answer. X minus 1 times x plus 4. And it matches, so we were right. All right, let's look at our next example. K squared plus 3k minus 3k minus 9. So I'm going to take each of my 4 terms and I'm going to write them inside of the boxes. K squared plus 3k minus 3k minus 9. What will we put outside of this box that will multiply to k squared? A k on this side and a k on this side. To get 3k, what can I multiply by k that is going to give me 3k? Hopefully you said a plus 3. And then I look at this box and I say, hey, what can I multiply by k to give me negative 3k? Or what can I multiply by 3 to give me negative 9? So to get negative 3k, I can multiply k by negative 3. And this should be right because 3 times a negative 3 gives me a negative 9. So my 2 factors, one would be k plus 3, and the other factor would be k minus 3. So I'm going to use my calculator to check. Remember, I can't put k's in my Desmos, but I can put x's. X plus 3, x minus 3. They match, so we were right. All right, let's take it up a notch. We are still writing a 4-term polynomial in factored form as 2 parentheses. The only difference is now my quadratic term has a coefficient. When we look at all of our other quadratic terms, they all had a coefficient of 1, aka they did not have a number in front of the variable, so it was fairly easy. It's still going to be a little bit easy. We just got to take a couple of extra steps. So I have already written my 4 terms inside of my area model. The goal is to find the common number of the coefficients and the letters from each row and each column. Let's look at the first row, and I will highlight it just to keep us all focused on the same thing. So I'm looking at this row, which means I'm looking at the 4b squared term and the negative 6b. The first thing I like to do is look at the letters. Like if I imagine that the 4 is not here and it's just like a b squared. Well, if it's just a b squared, what will go outside of this box? Like what 2 things can I multiply right here that would give me b squared? And if we look at our previous examples, hopefully you said a b and a b. But I also have to look at my coefficient, aka the number in front of the variable. So I'm still looking at this row, but now I'm looking at the 4 and the negative 6. So I'm trying to find what's the common number, the greatest common number between 4 and 6. So I gave you this factor pair list at the beginning of the year. It's in the front of your notebook, in the reference book. You're going to need it for the next couple of days. And so if I'm trying to find the greatest common factor between 4 and negative 6, I need to find that on my factor pair sheet. So on my factor pair sheet, here are the factors for 4 and here are the factors for 6. What's the biggest number that they have in common when I look at everything that's highlighted? Hopefully you say a 2. That's the biggest number that they have in common. So on the outside of this row, the greatest common factor would be 2 for my coefficients and b for my variables. All right, let's look at another one. So let's look at column 1, aka the one that's going down. So we've already done the variables. The variables are done, but we're just looking at the coefficients now. So now I'm looking at the coefficient of 4 and the coefficient of 2. So I want to know what's the greatest common factor, that's aka the biggest number that 4 and 2 have in common. So on my factor pair sheet, I'm looking at the factors for 4 and I'm looking at the factors for 2. What's the biggest number that they both have in common? A 2. So that means on the outside of this column, the greatest common factor of what they have in common is 2 for my coefficients and b for my variables. Now we can use these 2 terms that are on the outside to find these 2, or we can keep looking at our list of factors as well. It doesn't matter. So let's just look at the list of factors so we can kind of get used to it. So now I want to look at column 2. So I'm looking at column 2. And I want to know what's the greatest common factor between negative 6 and a negative 3. So I look at my factor pair list and I find 6. And I find 3. Well, what's the biggest number that 6 and 3 have in common? And hopefully you said 3. So that means over here I can factor out a 3. But notice they're both negative. So you kind of got to look at that in the aspect as well, because what can I multiply 2b by to get a negative 6b? It got to be a negative 3 because a positive times a negative gives me a negative. So when I look at this box, my coefficients are 2 and 3. So if I look at my factor pair list, I'm trying to find 2 and 3. When I look at the factors for 2 and the factors for 3, what's the biggest number they got in common? A 1. So that means I can put a 1 on the outside. Is it going to be a +1 or a -1? Well, 2b times 2b gives me 4b squared. 2 times -3 gives me -6. And 1 times 2 gives me 2. And 1 times -3 gives me -3. So my two parentheses, aka my factored form, would be 2b minus 3 times 2b plus 1. Let's check our answer and see if we're right. So I've already put the original in there. We can't put b's in here, but we can put x's. So 2x minus 3 times 2x plus 1. And they match, so we were right. All right, let's look at the next example. We have 2a squared plus 3a plus 6a plus 9. So we can go ahead and take each of our terms and write them inside of our squares. 2a squared, 3a, 6a, and a positive 9. This one's going to be fairly easy because everything is positive. So I'm trying to find out the greatest common factor for my first row, my second row, my first column, and my second column. It really doesn't matter which way we go, and I'll show you. So let's just look at this column. And I'm trying to find out what's the greatest common factor between 3a and 9. So really I just have 3 and 9 because they don't have a common factor of a, because both of these boxes don't have an a. This has an a, this one don't. That means it ain't common. Common means same. So I'm go over here to my factor pair sheet and I say, okay, there go my factors for 3. Here go my factors for 9. What's the biggest number that they have in common that I see on there? And hopefully you said 3. So that means for this column, the common number that they share would be a positive 3. All right. So we've done that one. Uh-oh, I think I took out too much. 3a and plus 9. I can write that back. All right, so then let's look at going across. 2a squared plus 3a. Well, I know this a squared tells me what will be outside these two boxes. An a and an a. But I also have to look at the coefficients. So that means for this column, I'm looking at the coefficients of 2 and the coefficients of 6. And so I go over here to my factor pair sheet and I try to figure out what's the greatest common number that they have in common. So I'm looking at my factors of 2 and I'm looking at my factors of 6. What's the biggest number that 2 and 6 have in common? Hopefully you said a 2. Therefore, at the top of this column, I can put a 2. So I have a 2a plus 3. And over here, I just have this a, but I got to figure out what's going to go on the outside of this box. So that means I'm looking at the coefficients of 6 and the number of what? 9. So I come over to my factor pair sheet and I find my factors for, and I find my factors of 6 and I find my factors of 9. What's the biggest number that they have in common? 3. So plus 3. So I have 2a plus 3 times a plus 3. Two ways we can check ourselves. Desmos, and then we can multiply. 1a times 2a gives me 2a squared. 3 times a gives me 3a. 3 times 2a gives me 6a. And 3 times 3 gives me 9. And so just to double check, we'll just type it in Desmos and see if the graphs match. And they do, so we did it right. All right, in our last example, we have 3n squared plus 7n minus 9n minus 21. So, and like all the other ones, we're going to write them in our box. 3n squared plus 7n minus 9n minus 21. So, for this box right here, I have n squared, which means what two letters are going to go outside of here. Like you should have said in all the other ones, an n and an n. All right. Now, we can look at the rows or we can look at the columns. So, let's do the column, which means I am looking at this column right here. So, my coefficients for this column would be 3 and negative 9. So, 3 and 9. So, I come over to my factor pair list and I find 3 and I find 9. And I say, hey, what's the biggest number that they both got on the list? And it will be 3. So, therefore, at the top of this column, I can write out a 3. Let's see if I can erase this without erasing everything. All right. Let's look at this row. I have 3n squared plus 7n. Well, we already took out the letter, so we're just looking at the coefficients of 3 and 7. So I'm trying to see what's the greatest number that 3 and 7 have in common. So I come to my factor pair list, and I find my factors for 3, and I find my factors for 7. And what's the biggest number they got in common? 1. So I can write a 1 on the outside of here, or I could just leave it as 1 as n. They both mean the same thing. All right. So let's look at this column. And I have 7n minus 21. I can look at this in a multiple ways. I can say, way number 1, if I want this to multiply to 7n, and I have a 1n right here, what can I put right here that's going to multiply to 7? Or I can say, hey, what's the greatest number that 7 and 21 have in common? Which means I will have to come to my little list over here, and I will have to find 7 and find 21. And then say, hey, what's the biggest number that they have in common? 7. So plus 7. All right. And then for this box right here, I can ask myself two things. What can I multiply by 3n to give me negative 9n? Or what's the greatest number that 9 and 21 have in common? So I come over to my factor pair list and I find 9 and I find 21. And I say, hey, what's the biggest number that they have that is common? Both of them have a 1. Both of them ain't got no 9. Oh, both of them got a 3, though. So that means 3 is the biggest number that they share. But this is negative 9. And if I want to multiply to negative 9, that means I would have to put it as a negative 3. Because a positive 3 times a negative 3 gives me negative 9. A positive 7 times a negative 3 gives me negative 21. So what would your factored form be? 3n plus 7, n minus 3. And then we can go to Desmos and check it. That's my original parabola. And then I put in 3x plus 7 times x minus 3. And they match, which means we're right. So I hope you guys have your factor pair sheets, because you will definitely need it for this lesson.